Okay, hello everyone, and this is our video on dun 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 CFCs.
Hey guys! Okay, so I'm Kathryn, and today we're going to be talking about CFCs. So you might be wondering what exactly are CFCs. Well, CFCs stands for chlorofluorocarbons, which is basically a chemical compound consisting of hydrogen, fluorine, carbon, and chlorine. So why are CFCs important? It's because CFCs were used to be made for refrigerants. And what refrigerants are is that they are things that you put in your refrigerator to cool it, and what makes refrigerators. So in the 1920s,
Jazz age. Sorry.
Okay. So in the 1920s, researchers were like, we want to make refrigerators, but the compounds used at that time, which were methyl chloride, were extremely dangerous. They were highly toxic. They could blow up at any second.
Dun, dun, dun.
And you don't want that for your refrigerator. So they developed CFCs. And this is the chemical structure for CFCs, one type of CFC. Okay, so we have the carbon molecule, fluorine, and the chlorine molecule. And so people saw the use for CFCs. And this one company called DuPont Company, right here, DuPont, they decided, hey, CFCs, we can make some money out of this, some really big money. And so they decided to call CFCs, trademark them, and call them freons. And so because CFCs were non-toxic, non-flammable, didn't explode easily, they were like, okay, let's use this, guys. And so they used CFCs to make aerosols, these spray cans, solvents, air conditioning, of course, refrigerants. And CFCs were making a giant name for themselves. But then in 1972, there are these three scientists. You can see here, right here. This guy is Mario Jose Molina, Paul J. Crutzen, and F. Sherman Rowland. They were like, okay, CFCs, I don't think they're going to work. But why aren't they going to work? It's because CFCs cause ozone depletion. Right over here. Okay. So you can see there's
the whole story.
Giant
Satellite images reveal the extent of ozone loss.
Dun dun dun. And you see right here, there's a giant hole in the middle of the Antarctic. So the problem, why do chlorofluorocarbons cause ozone depletion? Okay, so this is how it works. When CFCs, so we're gonna pretend this is a CFC. When you spray them with your aerosol or something, they go up into the atmosphere. And as we mentioned before, CFCs are extremely stable. They won't react with anything, which also means they won't dissolve in rain. Rain.
Ew, brown rain.
So,
okay, yeah.
then the CFC, they reach the atmosphere. So we have the Earth. I can't draw. We reach the atmosphere right here. Okay? And the CFCs, they go all the way up to the ozone layer, right here. And the ozone layer, it's very special because it protects the Earth, us, right here, we're all here, from harmful UV radiation from the sun. And UV radiation, they cause skin cancer, sunburns, bad things like that. And the ozone layer is responsible for protecting us on planet Earth. Now, the CFCs, they're up in space, chilling in the ozone layer. But then through a process called photolysis, right over here, the light, which in this case is the UV ray, they come and they're like, ha! I'm going to cut the chlorine from the CFC. And so now the chlorine is all by itself, and we call this the chlorine-free radical. And a radical is just a random molecule in space that
renegade.
that are broken away from the previous molecule. And now this chlorine,
off in his own business,
yeah,
doing his own thing, finding his own way.
So the UV ray, it breaks off the chlorine molecule, and we go over here. Ultraviolet radiation strikes the CFC molecule, causes chlorine molecule to break away, and then the chlorine collides with ozone. Now ozone, which makes up the ozone layer right here, ozone layer, it comes in contact with ozone, which is an extremely unstable molecule, and it always wants to find things to bond with. And so they see the chlorine, and they're like, hey, I want to bond with you, chlorine. And so they do. That means this oxygen molecule, breaks away from these two molecules, which means these two O's, they form a covalent bond, forming oxygen gas, and then the chlorine and the oxygen bond to form ClO, chlorine monoxide. And then, when the free atom of oxygen collides with the chlorine monoxide, so this is a random oxygen molecule and they hit the chlorine monoxide, the two oxygen atoms are like, hey, let's ditch the chlorine, let's make our own little oxygen gas, little universe thingy. And the chlorine now becomes a catalyst, which means this cycle repeats all over again. And so that means every single time a CFC molecule goes into the air and UV rays break it, it breaks down a lot of ozone, which causes ozone depletion, which you can see here. 1979, it was fine. And then when CFCs were starting to get introduced, there's a giant hole. Look at this hole. Look at this hole.
Okay, so ozone is basically the greens. The more blue stuff you see, the less ozone there is. So like less blue stuff, more blue stuff, lots of blue stuff. So,
yep.
Yeah.
So how did we fix that? Why isn't there that much blue stuff now? Well, it's because
there's still blue stuff. Okay.
Okay. Well, it's because of the Montreal Protocol. So in 1987, the world was like, we're screwed. We're screwed, okay? And so the entire planet Earth decided to come together into the UN and make this, the Montreal Protocol, right here.
One time the UN did something good.
Yeah, basically. And so all the nations came together to form an international agreement to phase out CFCs right here. CFCs. Because they realized that CFCs were terrible compounds. And so they did. And now, slowly and maturely, the ozone layer is coming back, and there's going to be more green stuff in the future. Because CFCs are done for, phased out. And so now, what about these aerosols, these refrigerants? Like, what do we do about them? Well, now there are new compounds, new research, and they've developed other things like HCFCs, which are better than CFCs, and other compounds to replace CFCs. So now, our world is back to normal, kind of, again. Okay, that's all. Thanks for watching.
Thanks, guys, and this concludes our CFC video on this amazingly interesting topic of chlorofluorine, yeah. Thank you.